So now we're going to look at the sum and difference of cubes. And so this also has a form similar to the sum and difference of squares. It's similar in the fact that it only has two terms, and you deal with addition and subtraction, but it does look a little bit differently. So now here, instead of looking for even exponents, we're looking for exponents that are divisible by 3. And when you get your a cubed plus b cubed or your a cubed minus b cubed, when you factor it, it's going to be a 2-term by 3-term. So when we factor it, your a cubed plus b cubed is going to look like a plus b, so it's your 2-term, times a squared minus ab plus b squared. And so even if you can't remember this form, you can always do division, long division, and then I'll show you how to remember the signs in just a second. So when it's subtraction, looks very similar, but your signs are different. So a minus b times a squared plus ab plus b squared. And so to remember your signs, what you can do is remember SOAP. And that would be same, opposite, always positive. So you've got the same sign. So if we started with addition, we have the same sign here. We have the opposite sign, and then always positive. Same sign, opposite sign, always positive. So that just helps you remember your signs, but remembering everything else is a little bit tricky. So let's work through a couple of examples. That's truly the best way just to learn math, is just by looking at examples. So we'll start off pretty simply. So first example, let's look at x cubed plus 125. So again, we've got those two terms. It is addition. My exponent here is divisible by 3. And then 125, maybe we don't know right off the bat that it is a perfect cube. But then after thinking about it, okay, 5 is a perfect cube. So 5 times 5 times 5 is 125. So this x cubed plus 125, so if we kind of break it down and look at it, the x cubed functions as my a cubed, and the 125 functions as my b cubed. So we're going to work it out, and we're going to simplify it a little bit differently for this one just to get us started. So if we're just trying to find our regular a, well, to get a cubed by itself, you would take the cube root of both sides. And so we would find that a is equivalent to x. I don't really like that pen. It's not showing up very well. Let's try blue. And then if we're trying to find the b, we can set it up the same way. So 125 is b cubed. And so to get b by itself, we would take the cube root of both sides. And so b would be 5. And so that could be helpful. You could just do that mentally in your head if you wanted to. So then we're going to use this form. So it's a plus b. So we know that a is x plus b is 5. So x plus 5. And then we've got a squared. So if a is x, we'll square it, and we've got x squared. And then we've got minus a times b. So a is x, b is 5. So minus 5x. We'll just go ahead and swap it so that the coefficient is a number. And then we've got plus b squared. So plus 5 squared is 25. And so that is your perfect cube factored. So we'll look at one with subtraction, and then we'll get a little more complicated. So let's do x cubed minus 64. So then over opposite side, here we've still got a is x, and b, if we take the cube root of 64, is 4. And so then, since it's subtraction, we'll have x minus 4, so same sign. And then we'll have a squared, so x squared minus, opposite. So opposite of subtraction is addition. So we'll have plus 4x. And then we'll have always positive plus 16. And you can always multiply that out to check your answer. Look at little bit more complicated ones, maybe some coefficients that aren't 1. So let's look at 8x cubed plus 27. So here I've still got an a cubed and a b cubed. It's still 2 terms. We know that 8 is a perfect cube. We know that 27 is a perfect cube. So now my a is functioning. So take the cube root of 8x cubed. It functions as a 2x. And then b, cube root of 27, is 3. And so it just gets a little more complex because I don't just have a coefficient of 1. And so then when we factor it out, we still have a plus b, so we'll have 2x plus 3. And then we'll have a squared, so 2x squared would be 4x squared, minus a times b, so minus 2x times 3, which would be 6x, and then plus b squared, so plus 3 squared, which is 9. And of course, you can check it by multiplying, so 2x times 4x squared does give you the 8x cubed. You can always think about it that way. So we'll look at a few more. This would be a short video. We can the bigger your numbers get, the less you might know by heart. So let's do 250x to the 4th plus 128x. So you might not know this, but 250 is not a perfect square and 128 is not a perfect square. But with any other time when you're factoring, you always want to take out a GCF first. So we're going to take out a GCF. My GCF, I believe, happens to be a 2x. And so when we take that out, we get 125x to the 3rd plus a 64. And so what happens is now we have 2 perfect cubes. So once we've got here, if we take the cube root of the first term, we get a 5x. And if we take the cube root of the second term, we find that b is 4. And so keeping that GCF on the outside, next we'll have a plus b, so we'll have 5x plus 4. And then we'll have a squared, so 25x squared, minus ab, so minus a 20x, and then plus 16. We'll look at one more. So this one will have a variable in both of them. So we'll do x cubed minus 216y to the 3rd. Actually, let's make them both have a coefficient. So we'll change this one to 343. So we'll make them pretty big. So 343 is a perfect cube. 216, believe it or not, is also a perfect cube. And both of my exponents are divisible by 3. And if we continue there, we'll just continue the same way. So a, the cube root of 343x cubed, is 7x. And then the cube root of 216y cubed, that's a perfect cube using 6. And so now we've got variables in both of them, but it functions the same way. All right, so we've got subtraction. So we'll use the same sign first. We'll have 7x minus 6y. And then we'll multiply it by a squared, so 49x squared, plus a times b, so 7x times 6y would be 42xy, and then plus b squared, so we would have 36y squared. And so that's a really basic explanation for sum and difference of cubes. They could get a little more complicated, but if they do, you always have that option of just using log division.